Alright guys, today we're going to do section 3 of unit 4, and we're going to talk about rate of change and slope. Okay, so a related constant rate of change to the slope of a line. So a rate of change is a ratio that compares the amount of change in a dependent variable to the amount of change in an independent variable. Guys, remember your dependent is your y and your independent is your x. So what this means is that the rate of change is the change in your y value over the change in your x value. So it's the change of the dependent over the change of your independent. So it's the difference of your y, change of your y, over the change of your x. This is subtract here. And you all should have seen this with our slope formula. Alright, the table shows the average temperature of 5 months in a certain city. We're going to find the rate of change for each time period, during which time period did the temperature increase at the fastest rate. Okay, so find the rate of change for each time period. Here's the first step we need to do. Second step, during which time period did the temperature increase at the fastest rate. So there's two things we need to do here. Alright. So let's go ahead and identify our x and our y, okay? Our temperature depends on the month, okay? So remember, x is your independent, y is your dependent. Okay, so what we have here is from this month to this month. This is how we write our relation, our ordered pair, our x and our y. So if we wanted to graph it, we could. But we're not graphing here. We're trying to find the slope or the rate of change. Okay. So here's my first point. Here's my second point. So to find the rate of change between this month and this month, I take my y values and subtract them. And I take my x values and subtract them. And I get 0 over 1. 0 divided by 1 is 0. So from this month to this month is 0. Okay? Now we go from this month to this month. So my relation or my point is 356. 563. I have my first point and I have my second point. And we're going to find the rate of change by using our slope. Find the difference of your y value, y2 minus y1, x2 minus x1. So when I do that, I get 7 over 2. So from this month to this month, I get 7.2. Okay? Now we got to go from this month to this month. So my point is 563, or my relation, 563, and then 771. I have my first point. I have my second point. Find your rate of change, which is the difference of your y, 71 minus 63, over the difference of your x values, 7 minus 5. Okay, and I get, let's see, what is that? 8 over 2, which simplifies to 4. So the rate of change from this month to this month is 4. And we got one more. Let's see if I can move this up a little bit. Okay, so our last one is going to be from this month to this month. So I have 7, 7, 1 as our first point, and I have 8, 7, 2 as my second point. Find the change of your y values, change of your x values. So the difference between these 2 months is 1. Okay, so let's go back up here. Find the rate of change for each time period. I did that. From the second month to the third month, it was 0. Third month to the fifth month, it was 7.2. Fifth month to the seventh month, 4. Seventh month to the eighth month, 1. Okay, so we did the first step. Second step. During which time period did the temperature increase at the fastest rate? Increase would be the steepest slope or the greatest number for the rate of change. All right, so that would be, let's see, it looks like the 7.2 right here. Actually, 7.2. Guys, this is wrong. This should be 7 over 2, not 7.2. It's this right here. All right? So the greatest rate of change is this 4. So to answer this right here, the increase at the fastest rate, it would be between months 5 and 7. So there's your second answer. Okay? So you have to find your rate of change, find your slope between each month, and then compare and see what the greatest one is. Okay, number 2 is just like number 1. I'm going to let you all do this one on your own, and I'm going to be quiet and do it silently. If you get stuck, you can look up here. Make sure you identify your x and your y first. Remember, your x is your independent, your y is your dependent. Okay, once you finish finding the rate of change, take the difference of your y and your x. You'll come up with 4 different rates of change. And the second one is find the interval that had the biggest decrease or the greatest decrease. The greatest decrease out of these 4 rates of change would be a negative 53. And that happened between day 1 and day 6. Okay, now what we're going to do is we're going to graph the data that we did from graph 1. So we've got our y and x axis. And our months, we need to go up to 8. To keep it neat, I'm going to go up with one interval, but I'm going to label every other tick line. And so this is our temperature. And let's see, we need to go up from 56 to 72. So I'll put a little break symbol. That little squiggly line means a break symbol. And we'll start with 56. Let's see. And I need to go up to 72. So what I'm going to do is I'm going to go up. Each tick line is going to represent 2. But I'm going to label every other tick line to keep it balanced. So 56, 58, 60, 62, 64, 66, 68, 70, 72. Okay? All right, so our first point was 256. Month is 2, temperature was 56. Second point was 356, month 3, temperature 56. Third point, 563. 563, we're going to estimate about right here. 771, all the way up about right here. And 872, about right here. Okay. So, let's connect our points. So this would be a continuous graph, not a discrete graph. Okay, so you should also be able to tell by looking at the steepness of the line which one had the biggest or the greatest increase, okay? Well, there's this slope here is 0. Horizontal line, there's no slope at all. This one has a pretty good increase, but this one is even steeper, okay? And it's between months 5 and 7, and that's where we had the slope. Let's see, the slope between 5 and 7, which would have been 4. Okay? So your greatest rate, well, let's see if I can spell great right. Your greatest rate, by looking at a graph, class, is by looking at the line that is the steepest.